My name is Karsten Ficker. I'm a civil engineer, and I've been here at LAMILUX for 20 years in various roles in application technology, in architectural consulting, and in product development. Over the years, I've done and gone through various responsibilities, and today I'm head of product management, Academy, and BIM. We were in France last year in a wind tunnel to test our products under realistic extreme weather conditions. We've been doing this for a long time, but France was a first. We have been testing our products here in-house for many years in a variety of ways, but there are limits here, such as the issue of dynamics, that is, moving and changing loads. We have often tested here in Rihau with water simulating heavy rain. Simply put, with the garden sprinkler. But where we reach our limits again is load and water at the same time, and that is the reason why we went to testing institutes. The advantage of the wind tunnel in France is that we can test very high wind speeds with very heavy rainfall at the same time. That is a unique thing, that you can test these particularly large devices with strong winds and heavy rain. These tests that we carry out are not standard in the industry because they are not required. There are product standards for all our products, but they are nowhere near as far-reaching. But why do we test them anyway? Quite simply because we prioritize customer benefit. We want to offer our customers exactly the product quality they need for their project and exceed industry standards, and offer, especially when it comes to extreme weather. Everyone has realized this in recent years, and it will probably be the case that we will have to deal with more and more extreme weather events in the coming years. We traveled to France with a small caravan. We had 4 products with us, starting with our glass skylight F100. We had our higher quality glass skylight FE with us, which is aimed at high quality living spaces, and the enhanced version of this is for special living spaces. That is, high quality loft flats with flat roofs and terraces, and we had our flat roof access hatch comfort square with us. And the most exciting experiment for us, our Rooflight F100 W, which was an absolute innovation at the time we tested it, and was not yet available on the market. It's a completely new wave-shaped dome, which is why we were particularly excited to see whether we could actually achieve the hoped-for effects with this high wave shape, that is, greater stability and higher rigidity for extreme values. For our flat roof access hatch comfort square, we were particularly interested in the situation when open. So imagine it like a sail in the wind with a size of 4 square meters. That was a test that was very important to us to find out if it really withstands real conditions. We tested up to 80 kilometers per hour, which is about 30 kilograms per square meter of dynamic pressure. So you can imagine about 120 kilograms shaking, pushing, and shoving the open wing. And it held up. We would have liked to test higher, but the wind tunnel wouldn't have been able to cope. We got into areas where the people in the wind tunnel started to have concerns, both in terms of their channel and because their confidence in our products were not as great as ours, in case something flew off. So we stopped at 80 kilometers per hour, which is more than enough for the real world. So imagine you have a convertible and you open up the top at 80 kilometers per hour. That's the situation we tested on the roof. When closed, we went even higher with the wind force. We tested at 144 kilometers per hour, which is more than Beaufort's 12. The Beaufort scale stops at 118 kilometers per hour, which means that at 144 kilometers per hour, we are actually already on the hurricane scale. What do we want to happen? The element must remain whole, it must remain closed, and, most importantly, if you have such a great flat in the attic, of course no water should get in, and that passed with flying colors, so it was also a convincing test for us. We were particularly excited about our Rooflight Dome F100 W, that is, this wave-shaped roof light. The closed state of the Rooflight Dome is particularly exciting because there are domes of 4 square meters that are inexpensive and very light with plastic glazing, which therefore tend to be lifted in strong winds. It's not unusual for the corners of a skylight dome to rise a little, and it doesn't necessarily matter unless it's raining. When it rains, it's bad if the corners are raised a little, and that's what prompted us to develop the LAMILUX Rooflight Dome F100 W. And now, the exciting question was, would it really work? We passed the tests with enormously high wind speeds and large amounts of water for a skylight dome. We had tested up to Beaufort 11, which is 108 kilometers per hour wind speed. To express it in terms of weight, we have just under 200 kilograms of dynamic pressure on the 4 square meter element, plus a bucket of rain per minute distributed over the surface, and everything inside stayed dry. And of course, we were very, very excited about that. We can now say that the Rooflight Dome F100 W has not only proven itself on the test bench, but also in the marketplace. At the end of the year, we produced the 10,000th of these skylight domes. 4 out of 5 Rooflight domes that leave our factory now have this wave shape, as you can see here. So this innovation has fully arrived on the market, and I can tell you that LAMILUX will continue to produce such innovations in the future. Such tests are the basis for this and the work of our developers, and we will continue to develop our products accordingly so that our customers get more than they expect.